maximizing. We're going to maximize area with fences, and we'll do some projectile motion. So the first thing we do here is we read this story about the farmer who has 2,000 yards of fence. So please draw a nice long piece of fence for me. And he has 2,000 yards of fence. Okay, so there's his fence. And he's going to enclose a rectangular field. We want the dimensions of the rectangle that encloses the most area. So there's lots of ways he can build a rectangle. Okay, so this is what we're going to do. I need you to chop off a piece that's X big. And we're going to put it there on the left X. Now this is a rectangle, so I need a piece for the right. So chop off another piece. Grab a piece X that's yay big, because if you're a rectangle, opposite sides are congruent. All right, now we still have two more sides to build. We still need a piece for the top, and we need a piece for the bottom. So take a look at this fence. I've already used these two. So how much fence does Farmer Abdul have left? 2,000 minus, take away those two X's. That's how much fence he has left. But he still has to build the top and the bottom. So however much is left, I need that to be divided by 2. So that means the top is going to be 1,000 minus X, and the bottom is 1,000 minus X. And if you add all four of those together, it better make 2,000 yards. Okay? Write an equation to represent area. Okay, A of X. Area of a rectangle is base times height. So that's going to be X times, make sure you use parentheses here, 1,000 minus X. Okay? A dot will just not cut it. Some of you are writing it like this. X times 1,000 minus X. That means that X gets multiplied by 1,000 and that's it. But I want the entire quantity, base times height. So you have to use parentheses. Should I distribute this? Yep, I think I'll distribute this and put this in descending order. So in descending order, it's going to be negative X squared plus 1,000X. Okay, so there's our parabola opening down. Finding the domain. We studied this last chapter, so the technique is going to be the same. For this rectangle to exist, I need the base to be more than nothing. Can't have 0 base. It wouldn't be a rectangle. And of course, you have to have the height be more than nothing. Okay, so take a look at the rectangle, and it doesn't matter what order you do this in. Some people always grab X for the base. So X is greater than 0, and then the other dimension, 1,000 minus X, has to be more than 0. A couple ways to do this. If you move the 1,000 over, then you have negative X greater than negative 1,000. And when you divide both sides by negative, you have to flip the sign. Some people say, well, can't I move the X over? And if you do that, if you move the X over, then you have 1,000 greater than sign X. And these are the same. Do you see how the arrow that greater than sign is pointing at the X? Okay, they're exactly the same. If you switch this around and write the X first, you'd have to stay pointing at it. So either way will get the job done. But for the overall domain, I have to put them together. I have to be more than 0, but less than 1,000. So it seems like X has to go from 0 up to 1,000. You always use less than sign. So there's your domain. Okay, just like last chapter. Let's draw a labeled graph. Okay, so we're always going to use quadrant 1 here. We're going to have 2 axes. We've got the x-axis. And let's see, where's my equation? See this equation right here? Is it x and y? Well, it's x and a of x. And what does a of x stand for? If you're not sure, just look at the directions for part B. It said make an equation to represent the area of this rectangle. So I'm going to call a of x the area of the rectangle. And what does x represent? A lot of people always say base, just like last chapter. That's fine. You could say base of rectangle. You could technically say a width or height, whatever you want. You'd be correct. Now you have to take your domain and put that information on this graph. So the domain goes from 0 all the way up to 1,000. All right, what is the shape of this graph? A parabola opening down. When you put 0 in, you get 0. So that means it starts at 0, 0. Parabola opening down, and it goes up to 1,000. So there's the shape of the graph. Oops. Let me move this up a little bit. Okay, let's go talk about the vertex. Let's go talk about the vertex up here. I'm going to call it H, comma, K. We always use the letters H and K for vertex. Okay, now what is H actually finding? H would be finding the base of the rectangle. And K would be finding the area of the rectangle. So let's do an H and a K calculation. So we've done this kind of problem last chapter with a calculator. Now we're going to be doing all of the problems without a calculator. So you could complete the square, or we could do our H and K formulas. So the H formula is negative b over 2a. So looking at our equation, which we've written nicely here in descending order, b is 1,000. So negative 1,000 over 2a. A is a negative 1. Cancel the negatives. 1,000 divided by 2 is 500. All right, let's do a K calculation. Give me a C. C minus b squared over 4a. There's the formula. C is 0. So you could write a 0, or you don't have to. Minus b. Well, b is 1,000, so I'm definitely going to write 1,000 times 1,000. Do not multiply numbers together. Save the numbers for canceling. Divided by 4a, and a is a negative 1. So let's go ahead and cancel those negatives. Let's see. Do you want to divide by 4? Or some people say, let's divide by 2. I'm not sure what the answer is for 4. So you can go at it in little bits if you want. So cancel him by 2. He's a 2. Cancel him by 2. He's 500. Okay, now let me tell you a trick. If you can leave 1,000 alone, then leave him alone. Keep messing up the other number, because multiplying by 1,000 is really easy to do. So I'll cancel 2, get a 1, cancel by 2, and get 250. So 250 times 1,000 means with 3 more zeros. So that answer is 250, comma 000. So if we go back to our picture over here, and I write these numbers on the vertex, I would put 500 first, and then 250,000 is the K value. So let's see what the question says. What dimensions produce the largest area? So it doesn't say find the largest area. It says what dimensions. What dimensions? And so for that, we need to go back up to our picture. The dimensions are the base and the height. So we need to know x. The x value is 500. So let's put 500 in for x, 500 in for x. 1,000 minus 500 makes 500. So this rectangle is 500 by 500. Let's not forget units. So the dimensions of the rectangle, some people like to see a rectangle like that, is 500 yards by 500 yards. Those are the dimensions. Dimensions are base and height. What is the largest area? Okay, area is the y value. We've already calculated the y value, and the area is 250,000, don't forget units, yards squared. Okay? So labeling these axes will help you understand what the X and Y or the H and K numbers mean, and that'll help you answer the question. Getting dimensions is always a good idea to look at the picture or draw a new picture with the numbers on it. Okay, let's take a look at another one. So we've got the Mayonnaise football team, and they're going to build a rectangular area. They're going to have like a little storage area for all their equipment up against the side of the field house. Oh, okay, so this is a little different. So they have this wall right here. Here's the field house wall. And then they're going to be making a rectangular area up against it like this. Put 3 sides of fence, and then that's where they'll put all their equipment. Okay? So what's different about this problem? When it's up against a wall, we only need to build 3 sides. So sometimes you have to build all 4 sides. Sometimes you only need to build 3 sides. Okay, so how much fence do they have? Let's take 1,000 feet of fence. Okay, and we're going to chop pieces of the fence off and build our rectangle. All right, so let's start with chopping off a piece X for the left. And since it's a rectangle, whatever you used on the left, we have to chop off for the right. So chop off another piece X, put it on the right. Okay, now stop and ask yourself, how much fence do we have left? We have 1,000 and minus, we've already used 2 X's. So what are we going to do with that piece that we have left? I only need to build 1 more side. So do I divide it by 2? No, not this time. You just take whatever piece of fence you have left and you use it on the 3rd side. Okay, write an equation A of X to represent the area. A of X equals, since it's a rectangle, we'll do base times height or length times width, whatever you want to call it there. And then we're going to go ahead and distribute. Do we have to distribute this out? And the answer is yes. How are you going to use the H and K formulas if you don't have an A, B, or C? So not only are we going to distribute, we're going to put it in descending order. So it's going to be negative 2x squared plus 1,000x. And the C value is 0 again. Okay, find the domain. Okay, remember how to do domain? You have to make sure that your base is more than 0 and the height is more than 0. Okay? Now, I keep calling it that because that's how we did it the last chapter. So we're just going to take these 2 dimensions. X has to be more than 0. Done. And then we have 1,000 minus 2x more than 0. This one we're going to have to solve a little bit. So I think I'll move the 1,000 over to the other side and switch sides, switch signs. I'm going to divide both sides by negative 2. Be careful when you divide by negative. Let's flip that sign and I get 500. So putting these together, the overall domain for this problem goes from 0 less than x less than 500. So I need to go from 0 to 500. My graph is going to show 0 and it's going to show 500. But if that base is 0, the area is going to be 0. So actually I want the picture that shows everything between 0 and 500. Okay. So what are the axes for this problem? The x-axis, look at your equation. Here it is. The x-axis and the A of x-axis. A of x is usually really easy to state. What is that? Well, that's area. Area of rectangle. If I was making a perimeter, I would have called it P of x. And I would have noticed right away it's a P. What is x? X is the base of the rectangle. Or you could say width of rectangle. What shape is this graph? It's a parabola opening down. And if you plug in 0, you get 0. So let's see, the domain goes from 0 to 500. If you plug in 0, you get 0. Parabola opening down goes like this. If you plug 500 in, you'd also get 0. So that means the area is 0 there, and 0 there, and the area that I want is somewhere between them. Okay, and if you found the vertex up here, that would be H, comma K. So it's time to do some H and K calculations. H equals negative B over 2A. Negative B is negative 1,000 over 2A. A is negative 2. So a negative and a negative cancel. 2 goes into 1,000, you get 500. 2 goes into 500, and you get 250. Okay, now remember, I designed all these problems, so I'm going to have the numbers come out nice. So please do not use your calculator for any of them, and get smart with numbers. K is 0 for C, minus 1,000 times 1,000 divided by 4A, which is 4 times negative 2. So the first thing I always try to cancel are the negatives. 1,000 divides by 2 is 500. Now remember what I said, try to leave the 1,000 alone because it's really easy to multiply by. Keep messing up the other number. I'll cancel by 2 again. So the 4 becomes a 2, 500 becomes 250. Is that an even? Yes, so 250 divides by 2 and you get 125. So 125 with 3 more zeros. Okay. So I like to write that over here on the problem just so that I could see what's going on. 250 was the H, 125,000 is the K. Question D. What dimensions produce the largest area? What dimensions? Dimensions are the base and the height of the rectangle. So let's go back up to the picture, and I need to know an X. The X value is 250. So this side right here is 250. And then what is this length going to be? 250 times 2 is 500. 1,000 minus 500 is 500. So that means that the rectangle looks something like this. 250 here, 250 there. Opposite sides congruent, 500 for the top and bottom. So what are the dimensions that make the largest area? What are the dimensions? 250, what are the units? They're way up at the top. 250 feet by 500 feet. Those are the dimensions that make the biggest rectangle possible. What is that largest area? The largest area, that's the Y. That's 125,000 feet squared. And you could always check, does this base times this height make this area? Feet times feet, feet squared. Okay? So the only thing you really have to remember when you're doing these problems, other than how to do them all, is if there's only 3 sides because it's up against a wall, then you don't have to divide that last remaining piece of fence in half. Otherwise, the approach to both of these is the same. Okay, now moving on to something